Well, right, I'll just explain this. Right, I printed some of these things out, and I found out that yeah, it's a bit tight. There's, yeah, tolerance wise. So what I'm having to do is right, is print some more canopies, but scale on the z-axis about an extra 0.2 well, 0.2 higher. So I've got a bit more clearance, but obviously I'll scale the fans down a little bit. No, I mean I've adjusted the height of the fans, because yeah, you can see it's just, yeah, it's just too tight in there. It's because this filament expands a lot. It's not very good. This filament's crap. So I twist my thing off. That's my stator. Now this particular fan didn't come out so well. I had to take some chunks off the back because I upset it a bit, but that's fine. It was the first one I did. The other ones are okay. That's this one. That one came out alright. So anyway, I'm just test fitting stuff, so I'm going to have to print another top fan anyway, but it's going to be a lower profile, so it won't rub anyway. But I thought, well, while I'm at it, I'll print some of these canopies and scale them up slightly, and nice tight fit once you get the damn thing in. Like that. And yeah, this one is a bit tight as well. Actually, I'll take that off a minute. Let's go this one, put that one in. It's not bad, this one. This one's not as bad, but there's no. I need about 2mm extra, so I've reduced the fan height by 2mm. I need a bit more clearance, that's all. So anyway, what I'm doing is I've scaled up these canopies, these drums. I call them a canopy because they're hollow on one side. Yeah, basically it seems like the appropriate name because they fit on top of it. You can stack them, you see. So anyway, so yeah, I mean they fit together really. These canopies fit together really well. It's just the fan blades, I got them a bit too wide on the inside. But this is the problem with filament, it expands when you're printing it, you know. So, and there's another one of my stators, which is static. I've been cleaning it up. It's a bit, this one, I use a bit too much acetone on it. It's kind of a little bit too, yeah, well, it'll work, it'll be fine. Here's a new one. This is the top. This one goes on the top. I've got to clean this one up. It's just come off the printer bed. This one basically goes in this top section. This is the bearing mount. The bearings fit in like that. I was testing the drive shaft yesterday. I was truing up the coupling on it. To show you what I mean, I'll get the motor a minute. Where is it? I wanted to make sure it was balanced right, so put this on the motor like this. Then I've got to hold the bearing in something. Oh, actually I could just stick it in the canopy, I suppose, can I? So I stick the canopy on it like this. Now you can't see a damn thing because the canopy's in the way. Well, let's turn it around. I'll use this towel. I've been testing the motor assembly for balance, you know. I want to make sure that this is trued up. This goes really fast, this motor does. I've got to make sure it's lined up first. Hang on a minute, my bloody computer's gone to sleep. So this motor is capable of going up to 22,000 RPM. Let's see if I can. I haven't tightened up the grub screws on here, so I'm just trying to get it lined up so that. Let's try it on that. It's a bit wonky on that one. Oops. There's an Allen screw around here somewhere. Where's the Allen screw gone? There, Allen key, I mean. I wanted to make sure my mechanical parts were up to the job, otherwise I'd have to go to engineering and get a new drive shaft made or something. But I could always 3D print a coupling thing between the motor and the drive shaft, but there's a reason why I prefer to use a metal one, and that is the heat sink. It will drain heat away from the motor. I don't want the motor to overheat, you know. It can take quite a bit of current, this motor can. I'll just tighten that up a bit. I've got a bit of. I had to drill this out because it was a smaller diameter drive shaft, so I had to drill it out. So I had to file it a bit because it got a bit off centre. Hang on. Still alright. It's all about just getting it lined up right. That's not too bad. I want some pliers on here because I just want to hold this one taking off. Actually, what I'll do is I can't stick the pliers through there. I can stick the narrow nose pliers through here, I suppose. I just wanted to test the motor itself, and right, if I stick that on there like that and then put the heavy pliers on the back, I just don't want this thing flying away. Let's see. Oh, I got it straight. There's a bit of a kink in it, and I'm trying to get that out. Not sure which end the kink's in at. Just a minute, it might be the other end. There! Oh, that was tight. Let's see. I'll have to get a better coupler, I think, off eBay. As I say, I drilled this out and my drill must have drifted a bit. It's a crap drill. Oh, that's worse. I've knocked it even worse there. There's 4 Allen screws on this thing, and you can adjust them. Ah, that's good. That's pretty good. Right, so I'll get this battery. Let's see what kind of a RPM we can get on this thing. I think that ends ground. Oh damn it, I can't lift that up. Yeah, I'm pretty sure that's ground. Let's make sure I haven't messed it up. Let's connect this end to ground. You'll get an idea of how fast this thing goes, really, I suppose. Right, I've got to hold the motor because it's got a lot of torque on it. Ready. This battery's a bit low. Oh shit. Oh, something wasn't level. Hang on. Something's not balanced yet. I know what it is. I need to tighten the other grub screw. Where's the other one that's loose? Right, this is where I'd put pliers on the other end, trust me. Right. There, that's balanced. That's a drive shaft test, that's all that is. I'll use the other battery now, hang on, because this battery's getting flat. It's pretty flat, is that one. Let's try these other batteries. This is a bit low voltage. Close to the rated voltage of this battery. The motor basically is supposed to be around 7 volts. You can see I've got it pretty well trued up. It's not bad. There's a lot of noise because the bearings are directly in this plastic and it's right resonating. Shouldn't be so bad when I get this thing together. Yeah, so that was just a motor test, really. Yeah, so as I was saying in the previous video, this is from the 1980s. I got this. It's a racing car motor, model racing cars. It's made by AKM. I don't think the company exists anymore. A King Motor Co Limited. This is before we had the internet, so don't think you'll find much online about it. But it was I bought it from the model shop, you know, where they do aircraft stuff and all that. And it's a good. I cleaned the armature commutator in it because it was absolutely chocolate black with carbon. I think what has happened was over time the carbon had just clogged the commutator and it was shorting out, so it was taking a lot of current, more current than it should. And it's healthy now because I cleaned it. It's got some torque, but it's not so much torque I'm really looking for. I just want to get the thing balanced right so that it runs at its maximum potential, at maximum speed. And if I have to get another coupler made or order another coupler for between the drive shaft and the motor, I'll do that. Or I could make something that's made of plastic that has a bit of flexibility in it. So this is another stator. This is the top stator. This basically goes in the top section. I haven't cleaned it up yet, but it goes in here like this, and it wants cleaning up. There's a lot of what do you call it? Baby bits on it. What's stringy? This is the problem with this. This is the problem with this filament. It's the stringiness. It's gross. I'll show you what I mean about the stringiness, how bad it is. This is why this filament is shite. Just look at that. Look at the state of that. I mean, just look at that. Look at the stringy crap on there. I've tried all the different settings in the printer. I've tried retraction. I'll retract the filament 10mm each time it does a hop to another point on the print. I've tried wipe nozzle. I've set it to wipe the nozzle before it moves to the next print layer, whatever. That still didn't make no difference either. This print material is absolutely shite, and it looks like the back of it looks like a camel's back, basically. If you look in there, it's just gross. It looks horrible, right? But at least when you have cleaned that off, the print itself is not too bad. It's a lot of messing about. And turning the temperature down would not help, because it will just make it even stringy. It will make it worse. The fibres won't stick properly, because as it is, the fibres aren't very well bonded. I think what it is the actual material doesn't have enough oil in it. It doesn't seem to have enough oil in it. I think it must be old stock, because it appears to. Oh, it's just recycled plastic. Its constituents are probably Chinese crap that they've just put in there and melted it all in with the plastic, and it's very dry. It's extremely dry plastic. It's like sandpaper, literally. When I'm cleaning this, the material is like, it's like, I don't know how to put it. How would you explain it? I think I've explained it as best I can. Most prints are fine. It's when it's doing small areas like thin blades like this that it seems to hang up. It seems to fail. In saying that, I was surprised I got the results I did with my turbine, because my turbine didn't come out too bad. But this material is not consistent. It seems to be inconsistent. In other words, it varies as you're printing off the spool. Some of it is extremely gassy. It just spits all the time. Other areas are less gassy, which to me just says it all, really. I mean, the material is just inconsistent. It's just not even. and this is why I have to acetone it, because I want it smoothed out, because it's as rough as a cat's tongue. I think I'll get my other knife. This knife, I've got a broken end on the end of it, and it's kind of useful for picking out. Look at that. It's not bonded. Look, it's cracked. Look, right there, it's cracked. I don't know if you can see that. It's broken away. So this is what I mean. I have to basically repair the splits with the acetone. So what I'm going to do is I'm going to put the electric iron on this copper plate, and I'm going to get this hot when I actually spray it with some acetone, and it will help it dry out, and it will keep it from warping because it will be on a flat base. Some of it I need a sharp knife for. I'm glad this is a stator, not a rotor. So I'm just basically printing the stators more than the rotors at the moment, because yeah, the rotors have got to be much more precise because they're spinning. These don't spin. So, right. I'm just about ready to spray it now. I'm just going to wipe this copper plate off. So I'll get my spray. Some of this is just so gross, it's just, yeah. I want to get the needle syringe on it, but I can end up with too much on, you see. It has to be even. The more even it is, the less warpage I get, really. I think that'll do. I'm gonna move it over here because I'm going to put the electric iron on. Really needs covering while it's, so it doesn't dry out too quick. Hang on a minute. Ah, bloody magnet. I'm just going to cover it while it. I want it to soak in a bit, you see. And I'm going to get the iron on here because I've got to heat it in a minute. It takes quite a while to get hot. And it's set to a low setting. Actually, it's set to it's below oh, what is it? I can't read it now. It's just below synthetics, so it doesn't get that hot. It's hot enough to make it stick to the copper and stop it warping. Basically, it's I think around 80 Celsius or something. I need to move stuff away from the iron because I don't want to melt everything. I don't want to melt my tools. Obviously move the acetone and stuff away from it. I don't want it so hot that it melts this plastic, this nylon thing behind you. And nylon, I think you need a higher temperature than what I'm using anyway, but it takes quite a long time to get this hot copper plate warmed up. It's just starting to feel warm at this end. It takes quite a long time for the heat to travel all the way through it, and it takes a long time to cool as well when it gets hot. But I'll be taking this lid off before it gets too hot. Because the whole point is to just get the acetone to soak into the plastic and bond and melt those ugly scars, and once it's done that part, it needs to be dried out, which is why I leave it on here for about an hour or two. Oh, Russell's done a video. Oh, Alan, yeah, I've got an RPM counter. It's on the. It's still on the magnetic motor thing. I could move that. I could put the RPM meter over onto this other device, I suppose. Yeah, but I mean, the motor is rated at 22,000 RPM at 7 volts, so I don't really need an RPM meter to know what it's capable of, because it says on the motor itself that it's 22,000 RPM maximum. That's without a load on. That's why it's important to get this bearing, this shaft perfect. This shaft is not the one that was in my magnetic generator thing. It's a different shaft. It's one I got off eBay. It wasn't properly. It wasn't turned on a machine. I think it was extruded because it's not perfectly straight. It's got a slight wobble on it, but it's not too bad. But I might get another dry shaft turned at the engineering firm. We'll see anyway. I'll try it first, see how we get on with it. I mean, I could probably balance it out. It just wants balancing out, that's all. Once I've got things balanced out, it should be fine. The motor, I mean, this shaft, actually, when I spin it with my hand, let's see, I don't know if you can see, but when I actually put it on the table, let's see if it's behind the actually I can take this thing off now, I suppose. Because that thing needs to dry out. When I put this on the table like this, and there's two bearings, one bearing, two bearing, and I just spin it like this. It seems true. Seems nice and true. I think it'll be fine. It's just getting the motor coupled directly straight properly. That's the main thing. Yeah. It's kind of interesting when I stick the fans on the end as well, like let's see, get one of these fans that I made, stick that on the end like that, nice tight fit, and pull this bearing back a bit, stick it on the edge of the table. It's interesting when the air is blowing at it from the other fan across the room, it actually turns. Now let me just put my finger on these bearings. I'm covering it up now. I'll just hold the bearings there. Oh, let's spin it like this now, show you what I mean. Look at that. I let go of it. Oop! It was spinning happily until the rubber caught on this end, this red end caught the rubber, and it run off the table. It actually worked quite well. It's quite balanced. Oh, there we go. Well balanced. Still going. It's just resting on, balanced on the table like that. This fan's a bit manky. I cut a piece out to balance it out. So Yeah, it's not jumping off the table, is it? Which is good. I've got the other fans better. I'm getting there. Let's see. This one hasn't been balanced properly though, it's slightly out of alignment, because if you turn it, it drops. So this one needs balancing a bit more, if you look. But it's better because it's not, I haven't cut any pieces out of it. You can see it just swings. Well, that's iron, but you might not be able to see that. Let's get a red dot on it. You'll be able to see that red dot. Now, this is what I mean, it needs some slight balancing to this one. If I turn it like there, ooh, turn it about there, it's resting on the bearings, remember, let go of it, you can see it's slightly out of balance, is that one. These bearings work really well. This is how I balance them out. This is basically how I balance stuff out. I find a heavy end, then I cut a piece out of it, out of an area that's not significant, that won't affect its performance very much. But I haven't really done that one yet. Another way is to stick a bit of lead or something in it. I could get my soldering iron and solder melt a bit of lead into that end to make that one a bit heavier. I could do that even. You know, it would probably work more effectively because the lead is it's quite heavy. But let's spin this one up. See if it leaks off the table. Oops. Oops. Ah. Oop, damn it. See it wobbling, look. See that one wobbling? It's out of balance. It's straight though, it's dead straight, it's just slightly out of balance. Look at it wobble. It's jumping off the table because it wants balancing out. So let's go and find a bit of leaded solder and melt some into it, and let me just make sure this is nice and flat. It's sticking to the copper now. It's gone squidgy and it's smoothing out. Right, well I've got some old bits of solder in here. Ooh, that copper's hot. Forgot about that. Now I can cut holes in it which tend to make a mess, or I can just get a bit of this solder, which is lead, mostly lead, and let's just put this on this corner and see if that's the right amount of material, because it's, I'll just nip it on my finger. It's going to fall off. I think that would work, because I mean, I'm talking about don't even weigh anything. Maybe I want to run a different setting. Ounces. Nope. What's OZT? I have no idea. It doesn't weigh anything. Hang on. What's DWT? I have no idea. Grams. Grams is best. Doesn't weigh anything. It's not even registering 1.1 of a gram. So I probably need a bit more than that. This stuff that I'm picking out of here, it's what came out my solder pump. So it's kind of hollow. Let's see what this weighs. Oh, 0.2 grams. Right, this piece here, this little tiny piece, is 0.2 grams. It's hollow though. It's interesting. It come out my solder pump. So what I need to do is turn this off. I need to find the right amount of material first of all before I press it in, if you know what I mean. So I need to stick this on here temporarily. What shall I stick it on with? Ah! Double-sided tape, that would work. Oh. Once I find the right amount of weight to add to this end, then I'll just get my soldering iron or something and melt it in. I tried cutting pieces out the other one and it just looks horrible when you do that. It's better if I stick some lead in it. So the double-sided tape will hold it there while we test it. Doesn't really weigh much. Right, I've stuck that piece of lead on there. That's perfect, I think. .2 grams. Huh, yeah. Look at that. The red spot, it will stay down now, it didn't come back up. Right, so 0.2 grams is what I need to embed. It's worth knowing as well, because in future, if the others are slightly out, it'll be about that as well. So, forget my soldering iron kit. Oops. Balance it out. Where shall I put it? This bit of lead. Well, I'll stick it in the. I'll just stick it in the back here. Actually, the front might be better. No, what I'll do is I'll stick it right in there so it doesn't stick out. So I'm going to melt that into this area. Wait for my iron to warm up. I don't want it to be too hot. Actually, I need to go down to 190 degrees Celsius. And I don't want to melt the solder because it'll all stick on my the tip of my iron, won't it? I want one of my discs because I don't want to poke all the way through. Bit like bicycle, because it was kind of hollow because it was out of my solder pump. It's gone really flat now. I think that's good. And just to make sure, I'll put a little bit of Super-Glue on it so it doesn't fly off. But that is balanced out now. And the Super-Glue where I'll stick a bit of that on, and it won't fly off and hit something. Right, that's that one balanced out. This is basically the process of balancing fans before you fit them. So this one should no longer wobble like crazy when I spin it. Well, not as bad as it was, it's a lot better. There's a bit of wobble, not much. I think that's good enough. I'll turn it the other way around and put it on backwards actually. Let's spin again. the red dot shouldn't swing around this time. Well, it did a little bit, but not much. It's definitely better than it was. Oh, it's there. Probably needs to touch more on there. But it's not as bad as it was, it's a lot better. I think it's acceptable. I mean, if this thing's going to spin at 22,000 RPM, it needs to be as balanced as well as possible. But then the other fans, if they're offset slightly, that would be another way of balancing it out. That's not bad. So just so you can have a look at the solder that I put on there. Get it lined up. It's just in the rim, on the outside rim. Oh, I've got a shadow. Yeah, that's it, behind the red spot. Bit of lead, silver. So that will be good enough, I think. I'm getting that sticky double-sided tape off now, because sticky. Right. God, its iron holds heat a long time. Oh, it's actually cool enough to pick out now. I think I can safely say that this has become jellified. Very flexible now. It's the heat. And when the acetone dries out, it'll be much more solid now, because the fibres are melded together with that acetone, so it's not going to fall to bits on it. This doesn't spin, this one, it's a stator, so, but it's not going to fall to bits easily, that's the thing. And that's all, folks, I'm afraid, because there's not much else to do right at this minute. I'm waiting for paint to dry, I'm waiting for prints. But that's my other motor mount I was showing you earlier. It's nice and flat. I treated it on this copper plate to straighten it out, because it started to curl a bit, and it's perfect now. So this is what they're supposed to be like. They're supposed to be all stacked like this, you know. I think I can turn the iron off now, because it'll take hours for this thing to cool, and this thing will dry out perfectly flat. It was flat to begin with actually, but I found out that when you spray the acetone on it, it will always curl and warp, so it's better to actually put it on the hotbed first and then spray it with acetone, and then let it bake a while, and then turn the heat off and just let it cool slowly. Then it will not curl up. Because what happens is the acetone binds some of the fibres close together, and because they're bound closer together, as it dries out they shrink, and then you get a curling effect, a warpage. It's like when you get if you got plimsolls, you know, like running shoes, you know, made out of that cloth material. They get wet and they get dry, and then they feel really tight because the material's shrunk and tightened up around it, so they're always very tight when you first put them on after they've been wet. And same kind of effect, the fibres basically close in, and the only way to avoid that and to basically stretch them again is to have it fixed on a copper plate or something while it's cooling and drying, and then it won't. That's the reason why stuff pops off a print bed when it cools, because it basically curls slightly and it pops off, or it shrinks actually, it pulls the edges in and it just pops off. Well, anyway, I'm trying to keep it as straight as possible. I don't want any curls or bends or warps or kinks or whatever, you know. Anyway, that's it for now.